Hello and welcome to my YouTube channel. Today we are going to learn about arrays and how to use arrays to make an LED chaser in Arduino using Proteus. So let's begin the video. So what are arrays basically? Arrays in C language is a collection of elements from a family of same data type. So when we say data type, it can be int, it can be char, it can be long, or any other data type. Okay, so these variables contain elements of same data type. Next, when any variable is declared in C, and if you are declaring it as an array, then all the elements in the array are allotted consecutive memory addresses. So they are not allotted addresses randomly, but rather they are allotted memory in the consecutive addresses. Then the most important point is that the indexing of the elements of an array starts from 0. So if you have declared a variable as an array, then the first element of the array will be indexed at 0. Let us try to understand these concepts in more deeper way. So how to define an array? To define an array, we need to have at least 3 elements. One is the data type, second the name of the array, and then in the square brackets you have to specify the size of the array. That is, how many elements are you going to allot in the array. Second way of defining an array is first inform about the data type, space, then after that name of the array. Then in square bracket you can specify the array size, and you can even initialize the elements in curly braces. Okay, so in this way we can either define an array or even initialize an array. Let us take some examples. For example, int, which is the data type, marks is the name of the array, and 50 here shows the number of elements which are going to be in that array marks. And all the 50 elements will be of data type integer. Next, for example, instead of int, you can even use other data types like float. Then the name of the array is grades, and number of elements that you are going to allot to this particular array is 25 or R25. Third example, we can even keep characters in the array. For example, char is the data type, name is the name of that array. There are 6 elements in this array, and here I am saving DEEPAK in the name array. Let us try to understand how this array is arranged in the memory and all. So first of all, like I said, the indexing starts from 0. So name square bracket 0, the first element is indexed at 0. So the first element is indexed at 0, and the element's value is D, or the character is D. Similarly, the second element is indexed at 1, and the character is E. And similarly, if we keep on going, the last element is 5, indexed at 5, sixth element indexed at 5, and the character is K. So in this way, the array is arranged in the memory. So in short, we can say the notation of any array is A of I, where I specifies the index of the element. And remember, the indexing starts from 0. Therefore, the first element of any array is indexed at 0. So let us talk how the memory is allotted to these elements of the array. So suppose if we are declaring an element or a variable marks, and data type is integer, and we are going to allot 10 different elements in this particular array. So here we have the addresses. So starting from 2000 to 2000 So these are the 10 memory addresses allotted to the variable marks. Okay, so now the question here is, you can see here all the memories are in consecutive order. They are not randomly arranged, but you can see it starts from 0, 1, 2, 3 and so on up to 9. So all the elements are arranged in consecutive memory addresses, and the indexing starts from 0, then 1 and so on up to 9. So this is how the memory is allotted to the elements of any array. And what are the things that we can do, or what are the algorithms we can apply on these particular arrays? We can directly change any element of the array by just telling about the index and introducing the new number. For example, marks, in the square bracket we have the index 8. So you can check here, index 8 is here, okay, and current value is 65. Now after passing this command, we can enter 50 directly to that particular index. So this way we can change directly the value of those elements. Secondly, we can even do arithmetic and logical instructions, or we can apply them directly on the arrays. For example, marks 3 plus marks 4, and the result of this summation will be stored in marks 6. So the index 3 is here, third index and the fourth index values 30 and 50 will be added, and the result will be stored in the sixth element here. So let us check. So this is how the arithmetic instructions are allowed to be performed on arrays. So 50 plus 30, you can get 80 directly in the sixth element. Similarly, if you want to initialize all the elements of an array with 0, then you can directly specify the number of elements, and then in the curly braces you can just leave it blank. So just simple curly braces, and that will actually initialize all the elements with 0. Okay, so here we are taking an example where the addresses are starting from 4000 to 4000 and you can see here all the elements are 0. Okay, so the indexing starts from 0 and reaches up to 3. So please keep this thing in mind when dealing with the arrays. The most important confusing part is the element 1 is indexed at 0. So the indexing starts from 0. Okay. Now, what are the advantages of using arrays to write any program for Arduino? First thing is that arrays can reduce the size of Arduino program. This is one of the best thing about arrays, that you can reduce the size, and if you are going to apply a same algorithm or same arithmetic instruction on any particular array, then in that case this program will be much smaller than applying the same instruction again and again. Second thing about arrays is that they generate efficient program, especially when you are going to use conditional or branching related loops. So if you are going to apply same instruction for all the elements of any particular memory, then in that case it will be better to go for arrays rather than writing the code again and again. So this is one of the best feature of arrays. Third, if you want to have more in-depth knowledge about arrays and how to use them in C programming, then you can check my YouTube playlist on embedded C programming, and I will provide the link in the description of this video. Now let us try to simulate a simple program to write to make an LED chaser using arrays. So let's begin with the program. So I will open the Proteus. Okay, in the Proteus, let me just start with the bare minimum. Okay, and let me start with a new project. So let me just close this particular project, close project, and I will start with a new project. So for that you can go to new projects, and in this you can just type the name of the project. For example, I will name it test array. Okay, and I can save it on my desktop. For just time being, I'm going to save it on my desktop. Okay, so new project, next, next, next. So here when you reach to wizard firmware, in that case you can just go to create firmware project, family Arduino, and Arduino Uno. Rest leave all the things intact, don't change anything. Okay, then go to next and then finish. Here we can see the schematic is created, and apart from that we have the source code, and I will just paste my source code here. And then now let us talk about the code and the schematic. So this is the schematic which is auto generated for the Arduino 328, and let us go through the source code. In the source code, first of all, I am declaring a variable int wait time, and this is the time delay which will be introduced between the blinking of different LEDs. So wait time is this value you can change. So the higher the value, the longer the blinking will take. Okay. Second, here we are declaring the array. So the array is integer type. Then the variable name is LED pins. Here we have the square bracket, and then in the curly braces we are introducing 6 elements. So 2, 3, 4, 5, 6, 7. So these are the pins of the Arduino board on which we will connect the LEDs. So we are going to use, or we are going to design an LED chaser with 6 LEDs. And then we are going to introduce another variable pin count of data type integer, and we are allotting 6 to that particular variable. So we are specifying that the array is of length 6. Now coming down to the setup, in this we are just writing a loop, for loop, to make all the pins of the Arduino, or the pin number 2, 3, 4, 5, 6, 7 pin of the Arduino to output. Okay, so this pin here you can see is taking the values. Okay, and we are going to start with 0 up to pin count. Pin count is 6. Okay, so here you can see pin count is 6. So this loop will keep on repeating for 6 times. Okay, so we can just directly tell the program that we are introducing 6 elements or 6 pins of the Arduino, and we are declaring all of them to be output. Then after that, coming down, you can see here we have loop. In this loop we are again introducing a for loop, in which we are writing the for loop for in this pin from 0 to pin count. Pin count is 6. So this loop will run for 6 times, and during this loop what we are doing, we are digital writing on the LED pins. This pin, for example, this pin here you can see it will start from 0, then 1, 2, 3, 4, 5, 6, and we are making it all high. Okay, and then waiting for a time period. Okay, and then making them low. So what will happen here? First, for example, LED pin, this pin 0. So LED pin 0 will become high. Wait for some time and then make it low. Then the loop will return here again, and the this pin will increment to 1. So this pin will become 1 and then it will become high and then wait for some time and then go low. Then this pin will become 2. So here LED pin, this pin will become 2. It will be high for wait for some time and then low. So in this way it will keep on repeating this particular function. So to make this circuit, we can come here on the schematic, and first of all let me first place 6 LEDs on this particular schematic. So for that I can go right click, components, from library, and I can just type LED, and I will go to optoelectronics, and in this I will take the LED. For example, I can choose any LED, but here I am taking LED yellow, active LED yellow, and then OK, and 1, 2, 3, 4, 5, 6. So in this way we have introduced 6 LEDs, and then we can bring them here and connect them all together, the cathodes of these LEDs, and make them connected to the ground. For that I will place the ground. So go to place, terminal, and ground. Here I have introduced the ground and connected, and then I can just connect all the LEDs cathode to the ground. So how to identify the cathodes? Simple. You can see here we have a triangle and then a single straight line. So the triangle is your anode, which is positive, which should be positive, and then we have the straight line representing the cathode, which should be negative compared to the positive terminal. So in this way we can introduce the pins. Okay, and then for safety purpose we can introduce a resistance. So resistor, go to resistors and choose a small value, something like 220 ohms or 330 ohms. So let me just take this particular resistor and rotate. Then instead of 1K I will make it 220 ohm. Okay, and then just then after that I will connect to the pin. So now I will just copy this, copy to clipboard, and then paste from clipboard, right click, paste from clipboard. So in this way I will repeat this resistor 6 times. Okay, and then okay. So now I will connect this to the LEDs. So done, connection completed in this way. Okay, now what I need to do is I have to connect the resistances to the pins. So I have to connect them from 0 to 6. Okay, I have to connect it from 2 to 7, sorry. So let me just right click and then just leave these lines like this. Just a second, it is not working. Okay, double click, done. And now I will start giving the place wire label so that I can directly connect to the pin. So I can just go to IO2. Okay, then next one, right click, place wire label, IO3, then right click, place label, IO4. Similarly this will be continued for all the pins. So IO5, right click, place label, IO6, right click, place label, IO7. So done. So this is our schematic and it is ready to be simulated. So before that, go to source code, build the project, and after the project is built, we can run the project. So it will take maybe some few minutes to just complete the building process. We have to wait for that time period, and in the bottom you can see the status. And once the project is built, now here you can see compiled successfully, so we are ready to simulate the project. So let us simulate the project. Let me just zoom it for okay. Now let us run the project, and you can see the chaser is working on this particular way. Now if you want to slow down this particular chaser, you can go to the wait time and introduce a higher number, for example 1000 here. So it will take 1000 milliseconds, that is 1 second, to switch from one LED to another LED. So rebuild the program. It will take some few seconds because building has been already done. So now this way you can see here the LED is shifting from one LED to another LED, or the light is glowing from one LED to another LED after every 1 second. This is how we can use arrays to simply write a very small program to make an LED chaser. Rather than writing 7 or 8 times the same command or same instruction, we can just make a simple small loop using arrays to make an LED chaser. In future I will show you how to use the arrays to connect with the switches. If you have multiple switches and multiple LEDs, how can we write small programs to read multiple LED switches and make multiple LEDs glow? So I hope this video was informative. And if you have not subscribed the channel, then I would request you to please subscribe the channel. If you have any suggestions or comments, then please put your comments and suggestions in the comment section. Thank you and have a nice day.